In this video, we're going to talk about lines and the coordinate plane, or the XY plane, as you might call it. So another large component of our course deals with linear equations and their graphs. So these could be in many variables, but for this chapter, we're going to stick to two variables. And when we have two variables in a linear equation, the graphs are always straight lines. Okay, so all the graphs we're going to be working with are straight lines. So let's begin with the talk about the Cartesian coordinate system, or the XY plane. So if we have a point in our plane, so points always have two coordinates. Okay, so a first coordinate and a second coordinate, so we write them as ordered pairs. The first coordinate tells you your horizontal direction, and the second coordinate tells you your vertical direction. Okay, so this point here that I've drawn, A, B, we've gone up B spaces, and to the right, A spaces. Okay, so here this point is going to be B, whereas this point is x equals A. Now when A is positive, that's when you move to the right. Okay, if A is negative, you're going to move to the left. Similarly, B positive means that you move up, whereas B negative means that we go down. And there's one special point on here. Okay, it's this point in the middle. So this is called the origin, and it has coordinates 0, 0 because we've moved 0 direction, either right or left or up or down. Okay, so this is the origin. And the horizontal axes, okay, so this axis here, we call the x-axis, whereas the vertical axis, we call that the y-axis. Okay, so the first coordinate is often called the x-coordinate, whereas the second coordinate is the y-coordinate. Okay, so they're telling you how you're moving in each direction. So often we want to think of the solution to an equation visually. So this is where we use the graph. The graph of the equation is the curve that contains all points, so x, y, that satisfy the equation. So let's just check a couple. So which of these, if any, points satisfy or on the graph of this equation? So 2x plus 3y equals 12. So what we have to do is just plug them in. Okay, so if we have the point 9, negative 2, this is my x, this is my y. I'm going to plug it into the equation. Okay, so that means I'm going to have 2 times 9 plus 3 times negative 2. And I'm hoping that that equals 12. So here this is 18, and 3 times negative 2 is negative 6. So instead of adding negative 6, I can subtract 6. So here I get 12 equals 12. Okay, so what this tells us is that the point 9, negative 2 is on the graph. Okay, now if we check the other point, negative 1, 4, and we do the exact same thing, okay, we're going to have 2 times negative 1 plus 3 times 4, and we want that to be 12. So this is negative 2 plus 12 equals 12. So we get 10 equals 12. Okay, so this is false. Okay, so we didn't get something that made sense. So that means that this point, negative 1, 4, is not on the graph of the line 2x plus 3y equals 12. Okay, so that's how you can check whether or not a point is on the line. in this course, we're only ever going to be graphing linear functions. So everything will always be a straight line. So what that means is you only have to find 2 points on the graph in order to be able to sketch the graph. So once you find 2 points, you just have to connect them with a straight line. Okay, that's going to be your graph. Now, one way you can always try to find some points is to use what we call a table of values. Okay, so that means I'm going to have x values, okay, and y values. And it's usually easiest if we pick x values. So for instance, let's say I pick x equals 0. This is going to give me y equals 2 times 0 plus 1. So y has to be 1. So that gives me a point at 0, 1. I get my first point. I could also pick a y value if I want. So let's say I have y value of 3, just to pick something different. That means that I need 3 to equal 2x plus 1. So I want to solve for x here. So I'm going to subtract 1 on both sides. So that means I'm going to have 2 equals 2x. So divide by 2. I'm going to get x equals 1. So that means I'm going to have a point at the 1, 3. So this first point was the point 0, 1. Now I'm going to have a point at 1, 3. So that's up here. Okay, maybe I want to try another point. Okay, what if I did, I don't know, x equals 1, negative 1/2. Okay, so then y is going to be 2 times negative 1/2 plus 1. So that's negative 1 plus 1, so that's 0. So around 1/2, I'm going to be at the point, negative 1/2, sorry, I'm going to be at the point 0. You can see that these are forming a straight line. Okay, 2 was actually enough to be able to graph this line. This is the point, negative 1/2, 0. Okay, but you can do as many points as you like using a table of values. Now, some special points that are on the graph, or on any graph actually, no matter the equation, are where the points where the graph crosses the x or y axis. Okay, these are called the x and y intercepts, respectively. So, if we have our coordinate, so our x-axis and our y-axis, okay, so if I have a point on the x-axis, that means that I have not moved up or down. So this is going to have coordinates x, 0. So the y value has to be 0. Okay, if I have a point on the y-axis, that means I have not moved to the left or to the right. So my first coordinate is going to be 0, and my second coordinate maybe will be some number. So here we have x equal to 0. This is precisely how we find these intercepts. Okay, so if you want to find the x-intercept, what you're going to do is set y equal to 0 and solve for x. Now notice that I wrote intercepts, okay, with an s there possibly. So for regular equations, it's possible that you have more, for regular functions I should say, it's possible that you have more than one x-intercept. Okay, here we are talking about lines, so they can only cross in at most one spot. Okay, so it's actually just intercept. Now to find the y-intercept, you want to do the opposite. So set x equal to 0 and solve for y. Okay, so that's how you can find those. Because these are special points that we often like to include on our graph, it's common that these are the 2 points that people find. So they plot them and then connect them to give you your line. So this works, okay, but it doesn't always work. So I'll give you an example of where it might not. Okay, so it could be that one of them is really far away from the origin, right? So maybe you have, I don't know, something close to the origin, and then x is like way over here. And maybe it just doesn't fit on your grid. Okay, so maybe I'll write, so too far from the origin might make this inconvenient. You can still do it, but it might be inconvenient. Another problem you might have, okay, is if your line goes through the origin. So I could have a line like this. So why is this a problem? So here, the x and the y intercepts are the same point. So when you find them, you only get 1 point, not 2. We need 2 points to graph the line. So here, you just have to find another point. Okay, instead. So you're going to have to find something else. So you might need a point, say, up here or something, so that you know which direction the line goes. Now, one of the most important features of a line is the slope of the line. Okay, this represents the steepness, we usually say, of the line, and it tells you how one variable changes with respect to the other. So the way that we find the slope is, so it's the steepness of the line. So you probably remember from high school that it's the rise over the run. Okay, so what this means is it's the change in the y values divided by the change in the x values. Okay, so let's just draw a little picture here. Okay, so let's say that this is my line, okay, something like this. I'm going to call it L. And let's say I have 2 points on the line. Okay, it can be any 2 points, it doesn't matter. So here, let's say this one is point x1, and this one is point x2. And then I'll have the y value, y1, going with x1, and y2 going with x2. So what we mean by rise over run is the change in the distances. Okay, so this from between x1 and x2, this is the run. So it's the horizontal change. From y1 to y2, okay, this is the rise. Okay, so it's the vertical change. So now the way that you find this, so to find the run, you're going to take either, okay, so either of the x values. So I'm gonna, in the picture, I'm going to do x2, and I'm going to subtract x1. So because I'm positive, this I'm on the positive x side, this makes sense. So x2 is this distance here, and I'm subtracting this part that I don't want, okay, to get the remainder part. So same idea here, I'm going to have y2 minus y1 for the rise. So that means that our formula for the slope, so we usually call the slope m, so it's the change in the y values, so y2 minus y1, over the change in the x values, so x2 minus x1. Now it doesn't matter what order you take the points, but the thing that you want to be careful of is that they align vertically. So notice I have both the coordinates that go with point 2, and then I subtract both the coordinates that go with point 1. Okay, now you could flip these around, it wouldn't matter, as long as you flip both the top and the bottom. So, a couple of notes about slope. So if m is a positive number, that means the line slants up to the right. Okay, but if m is negative, the line slants down to the right. Now for the first one, you could also say down to the left. Okay, and then the second one, you could actually say up to the right, to the left. So let me just draw a picture here for each. Okay, so a positive slope goes like this. Okay, so you're either going up to the right or you're going down to the left to be on the line. Okay, if you have a negative slope, okay, it's going to be sort of this way. So to get from one point to the other, you either go down to the right or you go up to the left. Okay, so this is when m is negative. Now also, the bigger that the absolute value of m is, so the m in magnitude, the steeper your line will be. Okay, so let me just draw an example. So a slope, I haven't done the axes, okay, but so this line might have slope 2, and then the line with slope 1/2 is going to be like that. Okay, so not as steep as the higher slope. Okay, but if it's negative, it's the same idea, but you have to use the absolute value because technically negative 2 is a smaller number than negative 1/2. Okay, so let's just quickly determine the slope of a line that passes through 0.76 and the point -5 or -4, 5. So I'm going to call the first point the point 1. Okay, so this is x1, y1, and point 2, x2, y2. So then m is going to be y2, 5, minus y1, 6, divided by x2, -4, minus x1, which is 7. So I get -1 over -11, which is 1 over 11. Now, just so you believe me, hopefully, let's change the order. So I'm going to call this point x2, or the point 2, and this one can be point 1. And then our slope would be 6 minus 5 over 7 minus -4. So I get 1 on the top, and 7 minus -4 is 7 plus 4, so I get 11. Okay, same answer. So it doesn't matter the order you put them, as long as they line up. Okay, so notice that the 7, 6 point is always above each other. Okay, and the -4, 5 point also always above each other. Okay, so they have to line up vertically. Now, what if we want to graph a line using the slope? So we're going through the point 1, 0. Okay, so I know I have a point when x is 1, y is 0. Okay, so here's the point 1, 0. And I have a slope of -2. So because the slope is rise over run, so it's like a fraction, sometimes it helps to think about these integer slopes as a fraction. So -2 is the same as -2 over 1. Okay, so that means that I'm going down 2, because it's negative, but 1 to the right to get another point. Or I could have actually written -2 as 2 over -1, in which case I would have gone up 2 and over 1 to the left. Now, actually, all three of these are on the same line, so it didn't actually matter which way I went. So this is the point positive 2, -2, and this is the point 0, 2. So depending on which version of the -2 you use, you get these different points. Now, there's a bunch of different ways to write the equation for lines. I'm sure that you've heard of all of these before. So the first one is slope-intercept form. So the way that's written is we have y is m times x plus b. Okay, now here m is the slope, okay, and b is the y coordinate, of the y-intercept point. So the point is the point 0, b. Okay, so you have the b, the y-coordinate. If you have it in point slope form, what that looks like is y minus y1 is equal to m times x minus x1. Okay, so here again, m is the slope. And now we have a point that the line goes through is x1, y1. Okay, so this point is on the line. For a horizontal line, they always look like y equals some number k. Okay, so for k real number. Okay, and they're going to have slope equal to 0. Okay, for the vertical line, you're going to have x equals some number. I'm going to call it h. Okay, for h, a real number. And here, the slope for vertical lines is undefined. Okay, so those are the main types that we're going to use. So let's just do a couple examples of finding the equation for a line. And I'm going to use the slope-intercept form for one of them and the point-slope form for another, just to be different. So let's hear, first I'm going to use slope-intercept form. So I have a point that's not the y-intercept, and I have the slope here. Okay, so that means that we know y should be negative 3x plus some number b. Okay, so this is the slope. Okay, that's from this. Now what I want to do is this equation should be true for all points on the line. Okay, so in particular, this point, it has to be true. So I'm going to have x is 5 and y is 4, and I'm going to plug those in. So 4 should equal negative 3 times 5 plus b. And now I want to solve for b. So 4 is negative 15 plus b. Now I'm going to add 15 to both sides so that it goes away on that side. And I get b is equal to 19. Okay, so that means an equation for the line is going to be y equals negative 3x plus 19. So you want to remember, if you're using this method, that at the end you write what your equation finally is. So after you find b, you have to then plug it into your initial equation. Okay, so for the next example, I only have 2 points. Okay, so I have 2 points. So I first want to find the slope. Okay, so I'm going to do x1, y1, x2, y2. So I have negative 4 minus negative 4 over negative 2 minus 8. So I get 0 over negative 10. What is this? 0 divided by negative 10, that's just 0. Okay, you can't divide by 0, but you can divide 0 by a number. Okay, you just get 0. When we have a slope of 0, we know that we're going to have a horizontal line. Okay, so we're in that category. But you can still use the slope-intercept form to find the equation. So we know that y is equal to 0 times x plus b. So that means y equals b. Okay, and we can plug in either of these points. Okay, so let's say we plug in negative 2, negative 4. Well, that means that negative 4 equals b. Okay, so we found our b. So the equation is y equals negative 4. Okay, so that basically you need negative 4 to be the y-coordinate, and the x-coordinate can be anything. I know that I didn't use the point slope form yet, but I'm going to do that in the next example. So we can also compare lines. So two lines are said to be parallel if they have the same slope. Okay, so what this means is that either they never intersect, or they are the same line. And intersect infinitely many times. Okay, so let's try an example. So what if we want to find the equation of the line that passes through the point 1, 2 and is parallel to this other line, x plus 2y equals 4. So in order to be parallel to this line, it has to have the same slope. So the first thing I'm going to do is take this line and put it in slope-intercept form. So to do that, we solve for y. Okay, so if it's in slope-intercept form, then we can determine the slope. So I'm going to subtract x on both sides, okay, to get the y by itself, and then I divide everything by 2, so this gives me y is negative 1/2 x plus 2. Okay, so this means that the slope for this line is negative 1/2. Okay, so since parallel, our line also has slope equal to negative 1/2. Okay, and then we know it passes through the point 1, 2. So I'm gonna use here this point slope form. So I know the equation should be y minus y1, which here is 2, and then equals negative 1/2, so the slope, times x minus x1, which is 1. So here I could be done, because it didn't say how I needed to give the line. This is an equation for the line. If you want to put it in slope-intercept form, all we have to do is solve for y. Okay, so we would just simplify. So this negative 1/2 has to go to both terms. So I get negative 1/2 x plus 1/2. And then I move the 2 over. I'm going to have y equals negative 1/2 x plus 5 over 2. Okay, now this would be the answer in slope-intercept form. So if it asks for that, we'd want to give it like this. Okay, but this answer is actually okay. So this is why I like the point slope form, because you get the equation immediately. So you're kind of done. Now, two lines are perpendicular if their slopes multiply to give negative 1. So i.e. m1 times m2 is equal to negative 1. So another way you can think about this is that they intersect at a right angle. So remember, a right angle is 90 degrees. Okay, so you can also, so normally we rearrange this so that m2 is negative 1 over m1. So we often say that the perpendicular slope, so I'm going to go like this, m pert, is the negative reciprocal, is probably what you've heard. Reciprocal. Okay, so you flip and negate to get the other slope. Okay, so one more example. So we want to find the equation of the line that passes through the point negative 1, 2 and is perpendicular to this line, y equals 3/4 x plus 2. Now this line is already in slope-intercept form, so we know that the slope is 3/4, which means that our perpendicular slope should be -1 over 3/4, or -4/3 when we simplify. Okay, so we have the slope and we have a point, so the equation is going to be y minus 2 equals -4/3 x minus -1. Okay, and again, you could be done here, but if we just rearrange, solve for y, this is +1, so then I times it by -4/3, it's going to be -4/3. And then I want to add 2 to both sides so that this goes away. So in slope-intercept form, it would be -4/3 x. This is going to be +2/3. Okay, so this is the answer in slope-intercept form. Okay, but in fact, all of these are fine, so this is the answer in point-slope form. So that is a brief introduction into lines and the coordinate.